Hi, I'm going to go through part H of question 1 on Mat 2007. So here we're given two equations in terms of integrals, and we're asked to find the integral between 0 and 2 of f of x. So this almost looks like simultaneous equations. They've given you two equations and they want you to find something. But I guess in its current form, it's not so obvious how we might use that. So let's try and simplify these equations a bit and try to make them more like simultaneous equations. So let's say that this is equation 1 and this is 2. So if we look at 1, then we see that we can pull out these constants to in front of the integral. And if we look at 2, then we can split this first integral up into the integral between 0 and 1 of f and the integral between 1 and 2 of f. And so we see the second integral is actually equal to the integral between 0 and 1 of f plus 2 times the integral between 1 and 2 of f equals 1. So now we see that we have everything in terms of the integral between 0 and 1 of f and the integral between 1 and 2 of f. So let's call I1 the integral between 0 and 1 of f, and I2 the integral between 1 and 2 of f. And then we get equations. Then we see our equations just look like normal simultaneous equations for I1 and I2, and what we're looking for are the integral between 0 and 2. Well, that's just going to be the integral between 0 and 1 plus the integral between 1 and 2. So what we're wanting to find is I1 plus I2. So if we solve these equations for I1 and I2, so if I take the second equation from the first equation, we'd get 2I1 is equal to 6, or I1 is equal to 3. And then we can sub this back into the second equation. We'd get 3 plus 2I2 is equal to 1, so we have that I2 is equal to minus 1. So if we're looking for I1 plus I2, then I1 plus I2 is just 3 minus 1, that's equal to 2. So the answer is D.